Two more to go. So this is question 40. Just remember that these are perhaps more complex than you would be required to do in the exam, but there might be simpler variants of these problems that you do have to solve. A new feature, rabbit attack, is to be added to the simulation. Rabbits emerge from one of the four corners of the field during springtime. There can be a maximum of 9 rabbits in one plot at any time. Each season, each rabbit moves either 0 or 1 space along each axis in any direction. So we need another emoji to represent this rabbit, right? So let's start by doing that. Let's put that in place. So we've got rabbit. And in this particular case, there is a requirement to sort of build on the previous task because you need to factor in when a rabbit eats a diseased plant. So let's just take the code from the last task as well, or the code that contains the solution to the last task. Okay, so we've got our rabbit emoji. Let's think about how we're going to do this. So a rabbit will be represented in the program code as a custom record type named rabbit. Each rabbit contains a location, an isAlive flag, and a hunger rating as its attributes. So when you want to have one sort of variable containing multiple properties, then we use class in Python, and your exam board says that this is this is how you implement a record according to the exam board. So we've got location, which is going to be X and Y. So let's maybe pass in an X and Y variable, and then let's make a coordinate to store the rabbit's location. And isAlive flag. So you can assume that if we're going to create a rabbit, then it is going to be alive. So isAlive will be true. And the last one is a hunger rating. And let's just read ahead a little bit. So the hunger rating do we have any information about the hunger rating? You can make the assumption that the hunger rating of a rabbit starts at 0. So when a rabbit first enters, it's not hungry. So this is the syntax for defining a record in Python using the class keyword. You need to define a special function called a constructor that has underscore underscore init underscore underscore. Its first parameter has to be self, and then you say self.location, self.isAlive. And this will allow us to make rabbits. For example, if I make a rabbit and call it Fred, then this variable will have all of these properties. I could make another rabbit and call it Jeff, and Jeff will also have its own version of these properties. This is this idea of how a record works. So we've done A, let's look at B. So update the simulation subroutine so the empty list of rabbits is created at the start of each simulation. Pass this list into any subroutine that now needs it. Read ahead below for clues. You also need to consider if the updated list needs to be added as a return value to the various user-defined functions. So it's a big change to the program. So an empty list of rabbits. And we're probably going to need to make sure that when we simulate a year, it knows about the rabbits. We're probably going to need to make sure that I think that will be it. And once we've finished simulating 1 year, we probably need to know about the rabbits. So we're now going to make a change to simulate 1 year, like the instructions told us. Rabbits is going to come in. Did I put that as the first parameter? No, the last parameter. Rabbits is going to come into the function, and it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function. And it then needs to be returned from the function But every time we simulate a season, okay, let's not jump ahead. Let's read ahead a little bit so we can understand the context a bit more. Update simulate 1 year, so at the start of each spring season, a new function, generate rabbits, is called. Okay, so this is probably where we need to generate some rabbits and put them into a list of rabbits. Now program generate rabbits. So let's make this function to generate the rabbits, which takes the list of rabbits as its parameter. And the idea is we're going to add new rabbits. When it's called, a random number of rabbits emerges from one of the 4 corners of the field chosen at random. So if we think about the 4 corners of the field, you've got the top left-hand position being 0, 0, the top right-hand position being whatever the value of field width minus 1 is, the last index, but still at 0. It's the other way around, isn't it? Well, still at 0 on the y-axis. And then we've got it so that the bottom right-hand corner would be the width and the length. And then finally at 0, but with the field width. But these are the 4 corners. So what we now need to do is make a random choice of one of those values. So we've imported all of the functions that are inside random. So one of those we have access to is choice, right? So we want to choose at random from this list, either 0 or either 0 or field length minus 1. And for the same for the column, either 0 or field width minus 1. And that will give us a random corner. We need to make a new rabbit instance, and we need to generate a random number of rabbits. How many rabbits? A random number of rabbits between 0 and 9. And then we want to, for I in range this number of rabbits, we want to make a new rabbit using the rabbit constructor from before. And remember how the rabbit constructor works? Well, we need to pass in an x and a y. So passing in the x and the y, our x value is our column, our y value is our row number. And once we've got the new rabbit, we can then append the rabbit to the list of rabbits. A new rabbit's hunger rating is 0. We did that before, and its x and y coordinates are set to the location that it emerged from. So this is the location that it emerged from. They all emerge from the same location. A message should be displayed to confirm how many new rabbits were generated this season. So I've decided to rename this variable. How many rabbits should just be called num rabbits instead. Num rabbits appeared this spring. So how does the program work again? Okay, rabbits only appear in spring, so that can be literal. Then once we've made or edited, extended the list of rabbits, we need to return it from the subroutine back to the calling point, which was simulate 1 year. So now we've got our new list of rabbits, and that needs to happen before the spring season, but probably after we've entered the disease chance, or probably after we've got our diseased plants. We put in our rabbits, and then we start to display. Well, you'll see in the example, actually, we print out season. And before we display, let's just get the sequence correct. Before we display the field, that's when the rabbits need to appear. Okay, moving on. So now we need to create an update rabbits subroutine that meets the following requirements. Every current rabbit in the rabbits list has its state updated at random. We need to move the rabbit 0 to 1 on each axis, and we need to make it so that it eats the plant or the seed and gets less hungry because of that. Or if it doesn't eat anything, we need to increase its hunger rating either by 1 or 2 if it's winter. We need to then kill the rabbits. Any rabbit that gets too hungry dies, and the same with diseased plants. If a rabbit ends up eating a diseased plant, it then dies immediately. A message should be displayed to inform the user to confirm how many rabbits died and how many plants got eaten. Okay, let's have a look. So define update rabbits. And we probably need to know about the field. We need to know about the rabbits. And we need to go through each of the rabbits. And we need to update the rabbits' positions. So for this rabbit, in the rabbits, iterating through each rabbit in the list of rabbits. Let's make a variable called row move, which will be a random integer between -1 and 1, because it can go backwards and forwards, or sorry, upwards and downwards. And for the column, it can go leftwards or rightwards, or generate 0, not move at all horizontally. So we need to consider what's going to happen if we just move, if we take the current rabbit, this rabbit singular, take the current rabbit and take its current location, take its x coordinate from the location, increment it by the column move, x for column. Do the same thing with the y-axis and change the row move. What should happen if the rabbit goes off the edge of the grid? We need to read ahead about this. Only rabbits that are alive are displayed on the field. Only rabbits whose x and y coordinates are within the bounds of the field are displayed. So we don't need to do anything yet. They're allowed to walk off the edge of the field. What do we now need to think? So we've just moved this rabbit. So now we need to check if this rabbit has eaten a plant or a seed. So we probably now need to get row or column and row out of the rabbit. So this is how we've got a list of a pair representing the coordinates inside the rabbit called location. So we can assign it to the column, which is the x, and the row, which is the y value. We can now check the field to see if at that row and at that column was either a plant or a seed. Is it in a list containing plant and seed? If it is, this rabbit gets less hungry. So the rabbit decreases by 2. And the plant or the seed needs to get eaten. So you can assume once the plant or the seed gets eaten, then it just turns back to soil, right? Equals soil. What are the other possibilities? Well, we need to think about, okay, what about if at this position there was a diseased plant? If there was a diseased plant, then the rabbit dies. How do we kill the rabbit? So remember, we set this flag is alive inside the rabbit class. So killing the rabbit can be represented as setting the is alive flag to false. So let's have a look. So we need to say, is this rabbit alive? No. Let's add a comment. Kill the rabbit. What are the other things we need to consider? So there's a lot to think about in this one. So let's add some comments so we can keep track of what we're doing. Rabbit moves between 0 and 1 spaces on the x-axis. We've done. A rabbit moves between 0 and 1 spaces on the y-axis. Done. If a rabbit falls on the same field coordinates as a plant or a seed, then the plant or the seed gets eaten. Plant or the seed gets eaten. And the hunger rating decreases by 2. Any rabbit that eats a diseased plant, this is any rabbit that eats a diseased plant, dies immediately. Or kill the rabbit. And then we need to check, okay, if it didn't eat anything, if this rabbit hunger rating goes above 3, then that's another reason to kill the rabbit. So let's, instead of, let's put that there. So if this rabbit, if at this position there was a diseased plant, or this rabbit has a hunger rating above 3, then kill the rabbit. Let's display our messages that we need to display at the end of the subroutine. So once we've finished iterating through all the rabbits and updating their state, we need to print this message of dead rabbits died this season and eaten plants. Well, let's just call it eaten dead. Dead rabbits died this season. Eaten plants or seeds were eaten this season. Let's make some variables for that. So assume that there are no rabbits dying or plants or seeds getting eaten. And let's make it so that, what do we need to do? So in this case, the eaten plant goes up by 1. And in this case, the dead rabbits goes up by 1. So will this work? Only rabbits that are alive are displayed on the field. Okay, so that's dealt with later. So do we need to... We don't, because of the way Python works, we don't need to return rabbits, but let's just do it anyway, because this is a subroutine. Let's do a good function interface. So rabbits comes in, the rabbits get changed, and rabbits comes out. And that gets called from here. So the next bit is... Doesn't get called from there, sorry, I'm getting confused. Simulate spring. Simulate 1 year. So that's when we generate the rabbits. Should be called from the end of the display subroutine. So moving the rabbits needs to get passed into display, because we're going to need to call update rabbits from display. So where's display? And update rabbits needs to take the field and the rabbits as its parameters. Field and the rabbits. So we've done that bit. In addition, display will need to be amended so it can display the rabbits. So we're looping through and we're printing the characters. We also then need to check, okay, instead of just printing a seed or a soil or a plant, we might want to print a rabbit, right? So we need to say something like if, or again, we're going to need to check all of the rabbits. So one thing we forgot to do was to add the parameter to the display function. So for this rabbit, for each rabbit in the rabbits, we need to check if this rabbit dot location is equal to this column and this row. That means that this cell contains a rabbit. So instead, char should change into rabbit. However, a single rabbit in a plot should be displayed as rabbit. If there are multiple rabbits in a plot, then the number should be displayed instead. So let's just go back to the example to have a look at this. You see, when the rabbits first appear, there are 3 rabbits in the same cell. So instead, the number 3 needs to be displayed. So we don't quite want to do that yet. We need to make a decision down here what to do. We need to count. Let's call it rabbits in plot is 0. Every time we find a rabbit at this position, we're going to increment this variable by 1. And once we've gone through all the rabbits, we need to say, okay, if this rabbit, or if this number of rabbits is bigger than 1, then the char should be the number of rabbits, converting the integer to a string. Otherwise, if the rabbits in plot is 1, that's when the char should become the rabbit emoji. Else means rabbits in plot is 0, so the thing we print instead is just whatever is in the field, presumably a plant or a seed or a soil. Okay, is that everything? Let's have a look. So we only need to consider rabbits that are alive. So let's just add that in. So if this rabbit is at this position and this rabbit is alive, and only rabbits whose X and Y coordinates are within the bounds of the field are displayed. So this should cover that. We don't need to put in a separate feature. Okay, let's test it. There's probably 100 bugs in this, but let's go through and fix them. Okay, it executes. Let's say no. Let's put in 0 chance for disease, and then we've got an error. So I've got a problem when checking the row and the column because we've gone off the edge of the screen, the edge of the field. So we do need to do some checking here because we can't index into the field if the row's gone above. So this is going to be similar to what we had before. We had check for disease, and this had this bounds check. So I'm now thinking it might make sense to put that into a separate function because we need to do it again. Let's make that a separate function. So let's say check off grid, field, row, column, and let's move that out. So if the row number's gone off the top or the bottom of the grid, we return true, or if the column's gone off the left or the right, return true, but otherwise return false. Fix the check for disease thing. So if check off grid is true, and that means we just need to return 0. So I'm just refactoring the code to have another helper function because I can see something that is being repeated in multiple places. So it makes sense. What's the benefit of having subroutines? You can write one block of code that solves multiple variants of the same problem, right? So if you get asked a theory question in section A about subroutines, this is one of the answers. So where was my error again? So field, this one. So what we want to do is if check off grid, field, row, col, we don't we can't check if it ate something, so we can just skip to the next rabbit. So I use the continue keyword here, skip to the next rabbit. Right, let's test it, let's see if it works. Okay, so we're getting the messages, and we had a rabbit appear, it seems. Oh, we had 6 rabbits. So that's something I need to fix. I forgot my f-string syntax here. So let's just go to display and fix that. Or to update rabbits, generate rabbits rather. So the rabbit appeared and we got a 6. There's a slight problem with the way that the grid is being displayed because of I'm going to say don't worry about it. So these Unicode characters have like a double width, whereas the number 6 is just a single width. So it's going to make the grid go a bit skew-iffy at the start. So then we can see the rabbits start to move. Looks like most of the rabbits moved off the edge of the grid and only 2 are visible. And then both rabbits moved back to the same location. So it started to display a 2. And then it looks like one of the rabbits moved off the grid. None of them have died yet. So let's run for another year. 0 chance of disease. And we're not seeing any rabbits die, which I'm suspicious about. Keep running the simulation. I would expect that the rabbits should be dying at some point. Okay, so we'll come back to that. I think there's possibly a problem with the rabbits not being able to die. So we've got another bug. Type error, unsupported operand type for rabbit and integer. So I've forgotten something from this line of code. Find it. So instead of decrementing, I can't decrement the rabbit. The rabbit's not an integer. I need to say the hunger rating that is what goes down by 2. Right, let's restart our test. So the rabbits appear. You can see now we've got the number has been fixed. So 6 rabbits appeared this spring. So let's see if we can get the rabbits to actually reach the crops. Okay, some success. So we've got the plants are getting eaten and that's getting recorded. But there's some sort of problem with the rabbits not ever seemingly dying. So what's wrong with our kill the rabbit function? So if this column has disease or the rabbit's hunger rating has gone above, okay, so we forgot there's no at the moment the rabbit is not getting hungrier. Remember what the thing that we didn't do is this one. So if the rabbit does not eat any food in a given season, its hunger rating increases by 1 in the spring, summer, and autumn season, or 2 in the winter season. We forgot to implement that. So if the rabbit doesn't die and the rabbit doesn't eat something, then we need to increase its hunger rating. This rabbit's hunger rating will go up by hunger. What should hunger be? Hunger is 1, but if the season is winter, and this is where we need to think, okay, we need now the value of season in the scope of this subroutine as well. If the season is winter, then hunger will become 2. Let's just update, where have I called simulate, update rabbits from? So that's from here. No, it's from display. And we need to also pass in season. Okay, let's test again. Let's see if it works. Okay, so let's see if we can get some rabbits to actually die at this point now. Okay, and it's working. We've got one rabbit died because they got too hungry. All the rabbits keep dying. So it's not going to be until the point where the crops reach towards the edge of the grid that we'll actually see the rabbits start to survive, because they're able to eat the plants and not die. So the more plants you have, the more plants and seeds, the more successful the rabbits will be at staying alive. Some of the other features. So what happens if we add in some disease plants? We should see the rabbits being more likely to die. Okay, so quite a complex feature, and it's quite hard to demonstrate that all of the different parts of this solution have been successful. So yeah, once again, this is more complicated than is required in the time limit of the exam, but it does not mean that a simpler variant of a similar problem, like adding some sort of new feature to the grid, won't be in your mock.